I'm happy to introduce Professor Turnbul. He is a neuropsychologist and a clinical psychologist. He was trained at Cambridge University, where he completed his PhD. He is interested in the study of emotions. He is currently a professor for neuropsychology at Bangor University, where he also serves as the provost of the university. Professor Turnbul is one of the leading figures in the community of neuropsychoanalysis. He is also an excellent speaker, and I am sure we are going to enjoy all of his 3 talks. Now he is going to talk about neuroscience for psychotherapists. Professor Turnbul, please.
I'm a professor in this old university. It's 140 years old now. It's in North Wales, in that part of Britain, so not next to London. And I live on that little island over there, just off the north coast of Wales, so I don't have to live in the expensive part of Britain, which is what London is. I'm sure Tel Aviv, you know about that too. We also run a small campus in China. These are our Chinese students coming to visit Bangor after their transition year. I run a brain injury and emotion lab because emotion is my great interest. And this is me with my local lab and also with our local brain injury team. And I run a summer school, a 1-week-long neuroanatomy summer school where we immerse people in things related to the brain. And that is my 50th birthday cake that I made for myself because I'm that sort of a person. Okay, and I have a very long association with neuropsychoanalysis. I've known Mark Solms, for example, for I think 30 years now. So I've seen the long journey that we have been on, and it's been wondrous. But I'm not going to start there because I've come to you from Britain. I'm going to start by talking about someone British. I'm sure we've all heard of William Shakespeare, the famous playwright and indeed poet who died just over 400 years ago now. And I'm also going to talk to you about Nelson Mandela, the famous politician and many other things. I won't describe him in too much detail. You know who Mandela is. And you have to be wondering, why is he talking about William Shakespeare and Nelson Mandela? And the answer is a linkage that happened in the 1970s, caused by this gentleman, Sonny Venkaramanthan, who is an Indian South African, who was exiled to Robben Island, as you know, the island just off Cape Town, which is where political prisoners were held. And when he was there, he took with him a copy of the collected works of William Shakespeare. Here they are. It wasn't clear that he could take any political works onto the island with him, so he hid the documents inside some religious cards on the outside. So these are Diwali cards, so that the guards would think that it was a religious book, not anything else. And besides, how dangerous can Shakespeare be, you might imagine. So while he was there in the 1970s, he got a series of the inmates in Robben Island to sign their favorite passage from the collected works. So we know of all of the plays which William Shakespeare wrote, we know what Nelson Mandela's favorite a few verses were. So if you would like to see that, here is the answer. It's part of Julius Caesar in a speech which Caesar gives to Calpurnia, and you can see it's been signed by Mandela in 1977. I'll read it out to you aloud. It is, "Cowards die many times before their deaths. The valiant never taste of death but once. Of all the wonders that I yet have heard, it seems to me most strange that men should fear, seeing that death, a necessary end, will come when it will come." So the essence of this line, which I'll return to a bit later, is that cowards die 1,000 times, the brave man dies but once. Why is Nelson Mandela so interested in this, given that he is in the position that he's in? But also, we need to remember the giant gulf that exists between these two men. They're about 350 years of time, 2 full continents, a whole range of cultures and races and attitudes and worldviews. But strangely enough, the words of this Renaissance Shakespearean speak to this African living on the tip of the southern part of Africa. Why is there this kind of transition? And the answer partly is that William Shakespeare is a genius, but it's not unique to Shakespeare. It's true for all sorts of great literature. I could have chosen a dozen examples, but the one I like to use most is the Lysistrata, the Aristophanes play, which also can still be played today. Usually in the audience is someone who knows the plot to the Lysistrata. So who knows the plot? Okay, very good. So one of you, could you describe it out loud for us?
It was actually played here just a few years ago in one of the theaters in Tel Aviv.
And the plot is?
Make love, no war.
Make love, no war.
The plot is that the women decided not to have sex with the
That's right. It's a war between two sides, I think Athens and Sparta, and the women go on a sex strike to say that until the war ends, we will have no sexual relationships. And I always ask people in the audience, how long did it take before the war ended? Do you know? The answer is 1 week. So, and people always smile when I say that. But this is a 2,500-year-old play. And yet it's still relevant today. You said correctly, it was played in Tel Aviv a few years ago. It was made into a film set in the gangster areas of Chicago last year. It's still relevant. And we have to ask ourselves, this incredibly important question, or at least I as a neuropsychologist want to answer this question. Why is it that we have people that can differ so much in so many different ways by our geography and our culture and our child-rearing practices and the languages we speak, vast differences, but yet this common narrative seems to spread across time and presumably across all of humanity. There is something that is very much in common amongst all human beings and something that is very different. And how, as a neuropsychologist, are we to explain this? And that's the journey, really, that I would like to try to take us on today, is to explain which brain areas we have that are in common, that will always make human beings have these shared phenomena, and which parts are different, and how that might explain the cultural differences and the world that we choose to live in. That's my challenge. And I'll come back to that at the end. And in order to take us on that journey, I want really to talk about emotion, which I will argue across today is the common theme that binds so many parts of the world together. I will try to summarize some of the neuropsychology of emotion, that it's long been ignored, what its biological basis is, and I will try briefly, I think, to speak, at least in the first talk today, about some relevance for psychoanalysis, for example, the number of the drives, and I will try to build onto the second talk that I'm going to give later, which is not about emotion, but about emotion regulation. So that's the journey, and if we're happy for me to go ahead, let's have a go. Let's remember also that emotion has been ignored by psychology for quite a substantial part of its history. The behaviorist revolution in the last century has a very clear attitude towards emotion, which comes in two varieties. Either that it exists, but we can't study it, or that it doesn't exist at all. And I prefer the Watson version, the founder of behaviorism, who suggests that studying behavior is a practical, a pragmatic, operational choice, that it's hard to study the mind, but mind, of course, exists. I can live with that, at least partially. It's the radicals, the Skinner psychologists that I struggle a lot with, and the quote which Jaak Panksepp, and I was so pleased you mentioned him earlier, we're so sad about his departure, always used to quote this line by Skinner, that the emotions are excellent examples of the fictional causes which we commonly attribute to behavior. So, for Skinner, emotions just don't exist. I have no idea how he manages to run his life, by the way, what happens when he has feelings. But, they believe that emotions don't exist. And as a result, it has stripped much of academic and experimental psychology of its emotional core. And here is a little survey we did a few years ago of the amount of time spent in textbooks. This is a Ramachandran textbook on the mind, which compares the number of pages which are dedicated to cognition versus emotion. And as you can see in this Ramachandran book, 38% of this dictionary of all of the mind, or all of the brain, I suppose, brain-mind, is dedicated to cognition, and 2% to emotion. It's ridiculous that something that's so important to human beings, which all students, when they arrive as undergraduate psychologists, think is very important, but often undergraduate psychology programs don't teach very much about feelings and teach them an awful lot about cognition. I would like to try to rebalance that situation. So what can we say about the biological basis of emotions? If I had been giving this talk in the 1970s, we would all have been a lot younger, of course, and some of us wouldn't have been born yet. But if I had talked then about the brain basis of emotion, I would have discussed hemispheric asymmetry and the differences between the left and the right cerebral hemispheres and how they are related to emotion. And the data that relate to those findings are simultaneously very accurate and completely believable, but at the same time, I think, very wrong and inappropriate in the context of what modern affective neuroscience has discovered. So that old literature, let's call it the classical literature from the 60s, 70s, and 80s, is very clear that the right hemisphere is very important. for example, for the perception of facial expressions, or for the production of facial expressions, indeed for the perception of heard emotions. So if you want to know whether a face is happy or sad or angry, then you need the right cerebral hemisphere in order to manage that process, and damage to the right cerebral hemisphere will reduce that capability. And I don't contest those findings. They remain as true as they were in the 1970s. I just contest their relevance because it's become clear that the things that the right cerebral hemisphere does has more to do with the cognitive aspects of emotion. That is, for example, the complex visuospatial task that is telling whether a face is happy or sad or angry requires that you understand, the precise movements of the outside parts of the skin, of the location of the eyes and the eyebrows, and so on. But that's very different from the visceral experience of being happy or angry or sad. That feeling of terror that overcomes us when we are very afraid. That feeling of joy that overcomes us when we have the thing which we have sought for so long. That is not the same thing as the experience, the ability to judge whether a face is happy or angry or indeed sad. And we have known those facts for a long time, and in the last 20 years we have become increasingly able to understand the brain basis of it, and there we need to look towards a range of subcortical brain areas, which I'll describe in a bit more detail later, to describe the visceral, the motivational aspects of the mind. So I'll show you some data that we produced, I think, in a paper last year to identify this distinction, which is not very much investigated. Here are some data on patients who are depressed. They are all bereaved for more than 18 months, and they belong to two categories. Either they have had a successful bereavement in the sense that they have been able to mourn the loss and overcome that, or in the 10 or 15% of patients who have what is usually these days called complicated grief, they are still, they haven't undergone normal mourning. Too fast. Okay. In 10 to 15% of these patients, they have not had normal mourning, and therefore they have complicated grief. They are still depressed after their bereavement. So we are comparing here two groups, both of whom have lost someone significant to them, but only one of whom have this long-standing complicated grief. And the answer, if you measure symptom magnitude, is that the complicated bereaved people have about twice the magnitude of any symptom that you would care to mention. They are still sad, they are still anxious, and so on. These are very powerful effects for these individuals. And I would like to show you the graph for their ability to judge facial expressions about whether they're happy or sad or angry faces, but there's no point because there were no significant differences under any of the conditions. So we have highly significant, 0.001 differences for feelings between these two groups, but no differences for the judgment of facial expression. It's a mistake, I think, or it's an important distinction to separate out the visceral feelings of emotions from the facial expressions, which we can see on the outside of the individuals. And we have known these data really for the last 70 years or so, since the work really of James Olds in the middle of the last century. This is electrical stimulation of the brain work in rats. They put a small electrode in the brain and they ask the animal to self-stimulate. That is, they have a choice between food and stimulating their brain. And a number of brain areas, most famously the nucleus accumbens, produces enormous effects of self-stimulation. That is, these animals ignore food in order to press the brain and produce what we might call a reward, if we wanted to use that word to describe it. And Jaak Panksepp, famously, is the modern variant and great pioneer of that journey. And it demonstrated in the middle of the last century already that what we need to know, the brain areas we need to be searching for visceral feelings are subcortical. The work that we've done across really more than a decade now in my lab has been producing the inverse of those data. That is, looking to see what happens to visceral experiences of emotion after cortical brain lesions. And the short answer is nothing. People after any kind of cortical brain lesion have no change in the felt experience, the magnitude with which they experience emotions. Indeed, if you measure the distribution of emotions across different emotional classes, they have the same range of emotions when we expose them to different kinds of emotional experiences. So the cortex is not at the heart of emotional experience, although it's responsible for some other very important things, especially for emotion regulation, which is what I'm going to talk about in my next talk. We also know, by the way, about the unimportance of the cortex for emotions because of some work that, again, happened a very long time ago in electrical brain stimulation. This is a paper that we published a couple of years ago, the only time I've ever got into the newspapers because it was on the neuroscience of erogenous zones. The papers were very interested in the erogenous zones part, but not very interested in the neuroscience, I'm afraid. In that paper, amongst other things, we reminded the community that since the middle of the last century, we've known what happens when you electrically stimulate the cortex. Penfield and Rasmussen were doing that work already in the middle of the last century, including stimulating the brain areas which represent the erogenous zones, the genitals. The short answer is you don't get erogenous sensation from stimulation of the cerebral cortex here. Here's the quote. Amongst 400 participants, curiously enough, we have never produced erotic sensation of any sort by electrical stimulation. The cerebral cortex is not the source of our felt emotion. It's very important for our emotional life. I don't contest that, mainly because it helps us to manage our emotions. It's very important for making us human, but it's not the same as the visceral experience of emotion. And here's yet another way of investigating those data. These are work by Tony Damasio's group 15 years ago now. The original work in functional imaging of emotions had invited people to look at those happy, sad, or angry faces and judge what the facial emotion was. And of course, they produced cortical activation. But Damasio, for the first time, invited people to have visceral experiences in the scanner. So he trained people to close their eyes and imagine themselves in a lived experience, for example, thinking about things which made them sad. And so the person in the scanner would think thoughts. He's left me, he's never coming back, I'll be alone forever, no one's ever going to love me. Very powerful emotional thoughts. Emotionally enough, for example, that in the sadness condition, these people were able to cry in the scanner, which is remarkable. It's not everyone who can manage that. These are the data for all 4 classes of emotion, but I'll show you the material for the sadness condition, because that's the one I talked about a few seconds ago. You'll see what the data look like. Firstly, subcortically, this is a section through the middle of the brain. You can see huge amounts of activation. This is sadness relative to baseline. Activation of the upper parts of the brainstem and forwards through the thalamus and hypothalamus through to the anterior cingulate cortex. So lots more activation of these very old parts of the brain. You will see that the data are symmetrical. That is, there's no difference between left and right, because at the level of the brainstem, there's no asymmetry in function in the human brain. And what about at the level of the cortex? You'll see there's no change for most of the parts of the cerebral cortex, but instead, in fact, in some areas in purple over here, there is deactivation. So these people who are thinking about what has made them sad are not having complicated existential thoughts. They're not planning what they're going to do tomorrow or imagining a different future for their lives. They're having simple, repetitive, they've left me, I'll be alone forever, my life will never be the same. The sorts of things that bother our patients in the psychiatric world, for which they have repetitive feelings. And it's these very basic emotions that are of the greatest interest to people like me. We've known since the middle of the last century that we can modify these by brain lesions, for example, to the hypothalamus and elsewhere. And we also know that these systems can be divided into a number of basic emotions. If I had a whole other hour to dedicate to this, I could discuss the politics of how many basic emotion systems there are. I think that the short answer to that literature is more than at least 4, but less than 10. And it sort of depends on how you choose to measure it. Here is Paul Ekman's approach to the problem, which identifies 6 basic emotions: happiness, sadness, anger, fear, and 2 others that are a bit contested, that is surprise and disgust. Jaak Panksepp has 7, but one way or another it also includes these same happiness, sadness, anger, and fear. These 4 are at the heart of what seems to us to be the range of basic emotions, and the literature will have to, over the next couple of decades, fight about which are the additional ones. I always, by the way, think about that in relation to the experience of being human. because if there are really only 4 basic emotions, happiness, sadness, anger, and fear, then what a tragedy that 3 of them are negative, that 3/4 of our emotional life should be about negative emotions. But it reminds me also, I think, that maybe in evolutionary terms, the safest way is to have only one accelerator and several brakes. You know, you get into less trouble if you have more things stopping you from doing stuff, and overwhelming optimism can lead us onto some very difficult paths, and we'll see a bit more about that in some of our later talks. Because these brain systems are more or less independent, not completely so, you can selectively lose individual emotions. Here's some work by my colleague, the late and now Andy Calder, on selective loss of disgust in a patient with brain lesion. I have a slightly disgusting slide to show you next. It's not very disgusting, but I'll show you what it is. This is from Ralph Adolph's work about selective loss of disgust. Patient B was unable to recognize disgust in any of the stimuli we used, including the descriptions of actions or spontaneous labeling of dynamic facial expressions. When told the story of a person vomiting, his descriptions of how the person would feel included hungry and delighted. When observing the experimenter act out the apparent vomiting of unpalatable food, accompanied by retching sounds and facial expressions, which means they went in front of them, B's description was that delicious food was being enjoyed, which I think is not an experience that anybody in the room here would have. Okay. So Jark has also been able to show, together with some other people, but he has been such a pioneer in this area, the extent to which these ancient brain areas are conserved. And I'll talk much more about that in my third lecture today. Here's a sort of cartoon chart of the anatomy of the human separation distress or sadness or attachment system, moving from the upper brainstem, the periaqueductal gray, forwards through the thalamus to the anterior cingulate. And here is his version of the guinea pig separation distress system. And as you can see from these color slides, basically, when it comes to this fundamental core emotion of sadness, there's no difference between guinea pigs and human beings. You might ask, what is the difference? And of course, it's obvious. Well, there are 2 main differences. The first of them is that guinea pigs don't have much cerebral cortex, which is why we're a little cleverer than most rodents. And human beings have this large cortex now enfolded because we've trapped it inside our skull. And the other difference, of course, is that the brainstem for the rodents goes horizontally because they're quadrupeds, whereas ours comes out vertically because we're bipeds. But apart from that, if it comes to the heart of sadness, I think guinea pigs get just as sad as human beings. In fact, as we'll see in my second talk, I think they might get sadder than human beings because they don't have the capacity to manage their feelings in the way that we do. But that's another matter. And the final issue which I want to discuss, but I'll take more time on it than other topics, is the link between these basic emotion systems and psychiatric disorders and indeed recreational drug use. And here I would like to point out something which is, I think, a huge strength of our community of intellectual life. And it reminds me, because I started out as an undergraduate studying physics, astrophysics indeed, about what the purpose of science, which is always to bring together different domains, you know, to take ideas which are disparate and somehow simplify them. And of course, I've put Newton up here because his great simplification, maybe one of the great intellectual achievements of the last millennium, is to realize famously that a falling apple, if we believe the apple story, which is attracted downwards by a force, is also the same force which allows the moon, for example, to circle the earth, or indeed us to circle the sun. So, you know, he says, here are these 2 things in the universe, these 2 phenomena that you would think are radically different, but actually they are the same thing, just viewed from a different lens. And I think that in our discipline, we are increasingly realizing that there are phenomena that are in 3 different chapters of our introductory textbooks, but are actually the same thing. And I'll tell you what they are, and then show you a couple of examples about that. And really, I think they are, firstly, that the basic emotion systems which I have described, I've done my best to give you a thumbnail sketch, are also, of course, the same systems that are modified by recreational drug use. That is, the reason why people take drugs is in order to modify basic emotion systems, or they wouldn't bother, you know, they want to change their feelings. And similarly, that these basic emotion systems are the ones that are modified in the pharmacotherapies of organic psychiatry. And I think realizing that these things which seem very different are actually the same leads us to a different way of trying to conceptualize the nature of the mental sciences, potential approaches to treatment, and also to bridge between the different approaches, the multidisciplinary team approaches which we are trying to build, which is why my colleague from the IPA, the local IPA, who stood up earlier and said he is interested in finding things that are in common between the psychotherapies and indeed the pharmacotherapies. This is the common ground for us here. I think emotion is the right way of cutting the cake up. Indeed, as Jaak has often so eloquently said, the DSM is not the right way of cutting the cake up. We need to have the chapters of the correct book of psychiatry defined probably by basic emotion system rather than by symptoms. But that's another story. Okay, so I see myself as sort of an introducer of ideas here for talks that are going to come, including Yoram's. Is Yoram in the room here somewhere? Not yet. He's a very last-minute chap, is our friend Yoram. But I'm warming you up. I'm the warm-up act for Yoram Evel, I suppose. And I want to remind you of some of these examples also because they introduce you to the importance of buprenorphine and suicidality and so on. So there are many ways in which I could give examples of these emotion systems and the way in which they relate to these three things. But I will choose the two most commonly described variants, which is a distinction really made by Kent Berridge 20 years ago now between wanting and liking. Hands up people who are familiar with the Kent Berridge distinction. Okay, then I will spend a few moments on it. So, of course, perhaps for some of you, you will have an overlapping understanding of this meaning, but hopefully in 5 minutes you'll understand the distinction that I'm trying to build. So wanting systems are things which expend energy. They allow us to go out into the world and investigate what's happening there in many different ways. The classic animal model is an animal in an open field sniffing around trying to find something interesting or going for a hike. As you can see, I live in a very green world in Britain. Slower? Okay. So it expends energy by sending us out into the world in order to try to investigate what different things might be out there. And it's pleasurable, of course. But it's pleasurable in a different way to liking, because liking systems, which are also fun, are not about going out into the world and spending energy to find the thing you want. They are what happens when you found it. They are what is usually described as the consummation phase of the process. And as you can see, in both of these cases, the people have found the thing that they were looking for, if that's the right phrase, and they are now consuming it. And it's very pleasurable, but it's a different kind of pleasure. As we can see from modern affective neuroscience, distinguishing between these two kinds of pleasure turns out to be very important. The energy expending, going out into the world type, and the consummation phase of enjoying the thing which you have then achieved. So let's spend a couple of minutes trying to see each of these systems viewed from the lens of my three categories that I said are really the same category. So let's talk about wanting first. It has all sorts of different names, of course, this system. Jaak likes to call it seeking, and he always reminded us to speak in uppercase capitals for the phenomena. Over the years, he also called it curiosity, interest, expectancy. Sometimes it's described as a reward system, but the languages of the way in which the mind manages things is often not the same as our languages. So we need perhaps many words in English or indeed in Hebrew to describe these phenomena. It runs anatomically from upper brainstem forwards to a range of cortical and indeed subcortical areas that you don't need to remember about the details of if you're not a neuroscientist. But famously, you will know that this system employs dopamine, a particular class of dopamine, sometimes called D2 dopamine if you're a psychiatrist, or mesocortical, mesolimbic dopamine, depending on your background. It's a close relative, but not exactly the same thing as the dopamine, which is important for movement and indeed affected in Parkinson's disease. So this system is important for a number of reasons for us psychologically, most importantly because it gives us energy to go out and explore things in the world. Indeed, Jaak used a wonderful phrase. I don't know if it translates, how well it translates into Hebrew, but he would say that this system is a goad without a goal. That is, it gives you the energy to do things, but it doesn't tell you which objects in the world you need to be interested in. It just gives you the energy to go out and investigate it. I think of it like putting petrol in your car. You know, you need petrol in the tank in order to drive your car, but there's nothing in petrol that tells you where to go. Whether you go to the beach or the library depends on the world that you were raised in, how you feel in that morning. You know, it doesn't describe the achievement. We also know that this dopamine system is very important for a range of linkages between objects in the world. Indeed, for the phenomenon that's behaviorists called auto-shaping. For those of you who remember your undergraduate lectures in learning theory, you'll know that when Skinner put his pigeons in the little Skinner boxes on a variable ratio schedule that is randomly reinforced them, he came back after a weekend and found superstitious pigeons. You know, one pigeon was in the back corner of the room, waving its bottom, and another was in the front right corner, scratching on the, scratching in the corner. And the answer is, of course, superstition. If you randomly reinforce people, then one animal happens to be in the back corner, moving its bottom when the reward comes out, and it thinks, maybe that was because I was in the back corner. I will spend more time in the back corner. And if you spend more time there, then you will get more rewards. And before you know it, you are superstitious, like people are superstitious about lottery numbers. You know, it doesn't have a good statistical basis, but people draw conclusions between them. And we know very clearly that increasing levels of dopamine increase this auto-shaping or superstitious behavior. So it's important not only as something which makes us feel good, but also as something which links together objects and causal relationships in the world. I know it's also important to find a good word for the subjective experience of the system, and the best word that I know of that we can use to describe it is a feeling of enthusiasm. It gives you energy to be interested in things in the world, and of course we can all be enthusiastic about different things. Indeed, on different days we can be enthusiastic about different things. So let's think about Freud. He, of course, famously described the use of cocaine more than 100 years ago now. Cocaine and the amphetamines are principal agonists. They increase the activity of these dopamine systems. And you remember I said earlier, if there's a basic emotion system and you can find a recreational drug which alters it, then people are going to want to take it. So this is a drug for increasing your enthusiasm, the sort of the opposite of that television program, Curb Your Enthusiasm, which I don't know if you get in Israel or not. Now, of course, these days, most young people seem to take this recreational drug in order to go out dancing because it gives you energy for the rest of the night. I'm not promoting drug use because, of course, you will burn your receptors out and then you will be exhausted the next day. But for a few hours, you can increase your enthusiasm for this process. But remember I said it's a goad without a goal. It doesn't tell you what the goal is. And Sigmund Freud's goal was not raving. He had 27 volumes of his collected works to write. So he says it gives him an exhilaration and lasting euphoria, an increase in self-control. It increases the vitality and the capacity for work. So he writes these letters to Martha, of course, in the middle of the night, saying, I've just taken some cocaine. It's really great. I can study really hard and write a lot of papers. So I think it describes the way in which the system can be increased by recreational drug use and allows you to do more things in the world. Of course, we can imagine the opposite of this, which is what happens when you lose the system. And the classic instance is von Economo disease or encephalitis lethargica, the disease, of course, from a century ago now at the end of the First World War, the Spanish flu, which selectively affected these areas of the upper brainstem. And for those of us who know Oliver Sacks's book and indeed film, Awakenings, you see these patients trapped, like Robert De Niro, in these frozen bodies for many decades until Sacks wakes them up by giving them L-Dopa. That is, he gives them a dopamine agonist to overcome the fact that they naturally have lost their dopamine. And they describe having many decades in suspended animation. That is, not only are they unable to move their bodies, which is what you see so clearly in the wonderful film, but also they were unable to move their minds. So they couldn't intentionally direct their minds, as you can, to think, what did I have for breakfast? What did I do in my last holiday? It was a sluggishness of the mind, an inability to have mental enthusiasm, if that's the right way of describing it. And finally, you remember I've said basic emotions are also the drug of recreational drug abuse and linked to psychiatric disorders. Of course, in organic psychiatry, the principal treatment for psychosis, especially for the positive symptoms, the hallucinations and delusions, are dopamine agonists. That is to reduce the operation of this basic emotion system. And here is the classic graph that shows the relationship between binder efficacy and dosage levels in dopamine. What I would like to mention here is, I think, a very important conceptual question for us. And that is, why is the drug which best treats the positive symptoms of schizophrenia something which reduces your enthusiasm? What is it about enthusiasm or a variant of happiness, about wanting, which is somehow at the heart of delusional beliefs? We need to try to understand that bridge in order to be able to solve the conundrum of why this is very effective. I'm not sure we've quite done that yet, but in my second talk, when I speak about emotion regulation and delusional beliefs, I'll give us some examples of that. And also to remind ourselves that by giving our patients these drugs, we are, on the one hand, reducing the level of their delusional beliefs, which is lovely, but we are also reducing their enthusiasm. And it's no wonder that they might want to fight against that, against that challenge. I think it's a very important issue for us. And I hope you can see now the ways in which these fields intertwine and make us think differently about the relationship between drug use and psychiatry and indeed basic emotion systems. So I've just showed you my example, my three-way example for dopamine, for the system that is about wanting, seeking the world, going out into the world to expend energy to find the thing you want. But can we do the same thing for liking? Well, of course we can. And I've already showed you some of that example. So the liking system, that is this emotion system that underpins liking, is also the separation, distress, attachment, loss system, which underpins much of sadness, if we have reduced levels of that, or indeed its inverse, if you're eating your bowl of ice cream in front of the television set. But also, we can remember the way in which, well, it's affected by a number of basic chemical systems. Jark is familiar usually with describing 4 of them. The most famous of them are the opiates, which is why Yoram, if he's going to be here, his work is so importantly linked to all of this. They describe the way in which increasing levels of opiates can reduce feelings of sadness and separation. And here is Candace Pert, the woman who in the 1970s discovered the endogenous opiate system, discussing the way in which she became interested in it before it became her doctoral work. She was out riding and had a back injury, so she was in chronic pain and had been admitted to hospital, and as a result was getting artificially increased levels of opiates through diamorphine. And here's her subjective description of the phenomenon. In addition to relieving all pain, it also seemed to completely obliterate any anxiety or discomfort I had as a result of being confined to a hospital bed and separated from my husband and young child. So this drug reduces feelings of separation, distress, and sadness. And let's remember the way in which, as a recreational drug, the opiates are completely different from the antagonists, the agonists of the system, the amphetamines. You take the amphetamines or cocaine if you want to increase enthusiasm and go out and spend all your night dancing. No one takes heroin in order to go dancing. If you've watched Trainspotting, or if you know someone who's a heroin user, you will know that you just want to lie down on the couch. You don't have any more problems in the world. You have temporarily, before you burn your receptors out, you have temporarily solved the problem of separation and distress. Okay, so I hope I've given you some idea about the way in which these fields potentially overlap. I think it has immense importance for the way in which we develop as areas of mental health, and I think especially for the relationship between the multidisciplinary team, so that we can try to line up the approach which is taken by organic psychiatry with that which is taken by the psychotherapies, or indeed approaches to solving mental health problems that are not psychotherapies, but are about treating the social circumstances of people, their family relationships, and indeed their larger social circumstances. if we understand that we are somehow trying to save our patients from these difficult feelings, I think it helps us to line up the different approaches to this problem in a way that potentially can be quite useful. But instead of speaking about practical things, let's remind ourselves a little bit about the metapsychology. If we had to talk about psychoanalysis, Freud famously has a couple, either 2 or 3, depending on your approach to psychoanalysis, basic emotion systems or drives, Eros, Thanatos, and indeed in psychoanalysis, the attachment systems. I think it's a little difficult for us to line up some of the basic emotion systems that modern affective neuroscience has identified with this, but we can do some things. The attachment systems of Bowlby and Ainsworth and so on, I think is very clearly the separation, distress, loss system that I talked about earlier. And a number of people, including Solms, have tried to make it clear that the libidinous concept that Freud describes under Eros, that life drive, has a lot to do with the basic emotion system that Jung calls seeking, and that energy system that leads us out into the world. I am no more able to solve the conundrum of the death instinct than 1,000 psychoanalysts across the last century, so I won't get caught up in that. But I think a reminder to us, which Freud said 100 years ago now, that biology, here's the quote, "Biology is a land of unlimited possibilities. We may expect us to give us the most surprising information, and we cannot guess what answers it will return in a few dozen years to the questions we have put." He always said that the drives were the most difficult, the hardest part of the mind to see, and that biology, neuroscience, was the best way in. So I think when it comes to discussing the drives, we are in a very good position to add something to psychoanalysis, although, of course, as our chair said earlier, it's very important for us to realize that talking 2 different languages means a difficult task of trying to reconcile them. So what can we say about the psychotherapies? I think the general perspective that our discipline is trying to work for is about the centrality of feelings, and indeed the idea that our patients suffer from feelings. That's the reason they come for treatment. And indeed, if we can get rid of the overwhelming, difficult, unmanageable state of these feelings, we can improve their worldview. And that's what I hope to talk about in the next hour, which is indeed going to be a lot about emotion regulation. So back to where I began in my last slide, in which I can make the slightly outrageous claim that briefly William Shakespeare was Nelson Mandela's psychotherapist. I think what he is offering here what Shakespeare is offering is a small defense for Mandela. And it's a defense we can all have in relation to cowardice and fear. And of course, bravery, let's remember, is nothing but the management, the well-managed nature of fear. We have fear that terrifies us. If we can contain our fear, then we are being brave. And so Shakespeare offers because he's Shakespeare, a little cognitive defense. He says, the brave man, the coward dies 1,000 deaths. The brave man dies but once. Shakespeare's sleight of hand is, of course, to compare 2 kinds of death. Cowardice is a sort of death, but if you agree with Shakespeare that they're both kinds of death, then the coward is dying 1,000 times, the brave man's only dying once. This allows the person who needs protection from fear to use this little cognitive tool as a way of protecting himself. Mandela, of course, is famously in a circumstance in which he needs to be able to manage his fear, and that, I think, is why he is able to, why he chooses this particular phrase. And it's also why it's always going to be eternally true that human beings are always going to need to learn to manage their fear. We're always going to need to be brave and to overcome cowardice through emotion regulation. And so the great works of literature are always going to speak to us, so long as we have these same sorts of basic emotions. So I hope that roughly on time I have finished, but last to say, I think we are trying to put the discipline, which has often had a little too much speculation in it, on a more solid scientific foundation, including links between psychology and psychiatry and indeed neurology. And as I'll talk about in my second lecture, also offers us a sort of an optimistic view in which we can have at last a neuroscience of psychotherapy, which will help our discipline enormously. And on that note, thank you so much for listening to me. I hope I haven't been too fast, and it's been a pleasure to be here. Thank you. Goodbye.